In the work sampling technique, we have seen that it gives us the percentage of occurrence of the certain activity, uh, and that is based on the statistical principles, and especially when the observations are taken randomly. So, statistical principles as well as when the observations are taken randomly, then it gives the observations with certain accuracy or with certain confidence level, uh, to see that whatever data has been collected through the random observation is representing to the actual situation. So how much confidence level is there and how much accuracy or possibility of error exists, uh, those things are also very much part of the work sampling. And the fewer the number of observations, lesser will be the confidence level, greater will be the error possibility. So when the number of observations are increased, our the accuracy, confidence level, as well as the number of as well as the percentage error decreases. So how many number of observations should be done in any case so that we have the desired level of the confidence in our results, as well as the desired accuracy or the reduced percentage of error is also there. So as per need only, we try to need of the confidence level and the desired accuracy or allowed percentage error, the suitable number of observations to be taken in work sampling, that is identified. So today primarily, first of all, we'll talk about how to identify the suitable number of the observations to be taken for a given confidence level, as well as the given error or the accuracy in the results. And so that will be taken up with the help of one example. Thereafter, other steps like how to design a form, how to take the how to find out or establish the time when these random observations will be taken, and then the advantages of this technique. So those are other simpler things. So we'll start this with our the approach or procedure for determining the number of work sampling to have the desired confidence level in the observations, and allowed percentage error, or indirectly we can say accuracy in the observation. Based on this requirement, we try to see what will be the number of observations to be taken, and that is done using this equation: P into S equal to K into sigma P. This is the standard deviation. So here P is the percentage of occurrence that is obtained through the say given set of number of observation. These may be 5, these may be 20, these may be 500. So that percentage of occurrence of something, like percentage of the idle time or percentage of the time when activity is taken out of the total number of observations. So just an example, 8 times the worker is found working out of the 10 number of observations. So our percentage of occurrence is here 0.08. Okay, so that's that's how sorry 80, so it will be 0.8, that will be the percentage of occurrence of the activity. Okay, so now the S is the allowed or desired allowed error, or we can say desired accuracy, which may be like say 5% or 10% of the error is possible in our observation. So that is what is the allowed error or the accuracy desired. K corresponds to the constant only, this set depends on the confidence level desired, desired in our observation. So as I said earlier, like say for 95% confidence level, this k value is 1.96. Okay, for 99% confidence level, this value is 2.58. okay, and then 99.9 percent confidence level, this value is 3.30. so as per the requirement of the confidence level in the observations, we use suitable value of the k, and whatever the percentage of occurrence that has been identified based on the number of observations we have made, what is the standard deviation for that, so that sigma p value is identified based on the number of observations which have been taken. Okay, so these are the this is the main equation, and that will be used for determining the number of observations. How? Because the sigma p, as we have seen earlier, sigma p standard of deviation is obtained from the simple equation of p1 minus p divided by n minus 1. okay, so n, p is the percentage of occurrence that we have determined, and n is the number of observations which have been taken. okay, this is the equation we used when n value is less than 30, and when value of n is greater than 30, then we use the equation is little modified, 1 minus p divided by n. Just remember this. So in that case, this simple equation is again get a little modified by k into, now we'll be writing this p 1 minus p divided by n minus 1. so n minus 1 or n, that will be taken as per the case. okay, so this is our the main equation. If we have got the p value, if we know the error that is allowed or accuracy desired, if we know the k value, then we can determine the value of n. But this is not determined in one go, it is very iterative process. So in the beginning, we may not be knowing anything about what is the percentage of occurrence. So you go randomly, go for certain number of observations and try to see what is the percentage of occurrence, and this may not be the correct representative value of the real situation. So that is why we don't know really for a given number of observations, whatever the p value has been identified, it represents to the desired confidence level or desired accuracy or not. That is why we start with some random observations and try to determine the value of p. okay, so say one example, it will go like this. So we don't know anything, so we started with the say 100 number of observations of a situation. Worker is working or worker is idle, like that. So say we are considering worker is idle, so the percentage of occurrence of the idle worker or idle machine, any case can be taken out of the 100 number of observations. If it is found that for 25 times it is found that worker is not working, so the p value comes out to be 0.25. if the desired accuracy, let me say, if the confidence level desired is 95%, okay, then the value of the k in this case becomes 1.96, and if the error allowed or desired is say 5%, okay, so 5% is the allowed error or the accuracy desired, so s value is 0.5, so 0.05, that is the allowed error. The p value obtained from the random observation is 0.25. okay, so let us put these things in a equation of p into s equal to what it was, k into p into 1 minus P divided by N, because number of observations are 100, so it is more than 30, so we'll use this simple equation. So like 0.25 into 0.05, that is S, okay, and 0.25 is the percentage of occurrence of the idleness, okay, and the K is 1.96, square root of 0.25, 1 minus 0.25 divided by N. When we solve this equation, we get the value of N is equal to 4610. So you see what it is suggesting, that if this is the tentative percentage of occurrence 0.25, then for 95% of the confidence level and 5% of the desired accuracy, we should have taken the number of observations, not just 100 but 4610. So we'll further increase the number of observations, and say further we took the number of observations. This is an iterative process. You will realize this gradually how it progresses. So if the number of observations taken 500 number of observations, and out of the 500 number of observations it is observed like 150 times the worker is idle or machine is idle, so this gives us the p value, say 0.3. okay, so using this p value of 0.3, again we will calculate the N. So here p value is 0.3, then desired error is or desired accuracy is 0.05 equal to 1.96, the same, then 0.3 okay, so 0.3 into 1 minus 0.3 divided by N. So when this is, we are simply repeating it, we increase the number of observations, and after that we try to see really what is the situation of the percentage of occurrence, and then we'll try to see if it is corresponding to 90% or 95% or 5% error or not, 5% error, 5% accuracy or not. So again we calculate the value of N, and say it comes out to be little less, say 4174. okay, so now we continued the observations either through the capturing images and then investigating those, or visiting the shop floor, whatever methodology is used, those things are done, and then after this, say continued these observations, say after 4000 number of observations, it is found that worker is idle for 1400 times. So this gives the value, corresponding value of P is 1400 divided by 4000, so it is say 0.35. so the updated value of the P is 0.35 now, okay, 0.35. so now again we'll be checking if this is as per the desired confidence level, desired accuracy or not. So again 0.35 into 0.05, that is the accuracy desired, then 1.96, that's a confidence level, coefficient corresponding to confidence level, then 0.35, 1 minus 0.35 divided by N. So this gives us the value of N equal to 2854, which means we have more number of observations for given the confidence level and the desired accuracy. So now we have got the more number of observations. Since we have got more number of observations for a given confidence level and given accuracy, means actual accuracy of the data that we have got in form of P is far better than what is desired of 5%. So what is the corresponding value of error what will be the value of error corresponding to those 4000 number of observations? So let us put it again, because we have taken the number of observations much more than what is desired for a given accuracy or given error and the given confidence level, then increased number of observations will certainly be increasing the accuracy. So what is the accuracy or the error now, which is there for corresponding 0.35 value, and say S we don't know because we have done it for much more number of the observations than what is desired. So we'll try to determine the accuracy or the error now when we have done the observations for more number of times. So again it will be done, it will be repeated again, say so square root of 0.35 into 1 minus 0.35 divided by n. N also we know here, so n here is say 4000. Okay, so 4000. So corresponding to the 4000 number of observations, this occurrence 0.35 of the p-value, confidence level of 1.96, 95% confidence level. What is the now accuracy that will be there in this data? So when we calculate the value of S, we find the percentage of the accuracy is percentage of error is say 4.22%, which corresponds to say 0.0422. Okay, so our so for now what we can say, for 95% confidence level with an error of 4.22%, okay, there is a possibility of occurrence of idleness. Occurrence of the idleness is how much? Like say 0.35, or it is 35% plus minus 35 into 0.042. Okay, 35 plus minus. So when this is solved, what we get? 33.5232 in the lower side, to the higher side is 36.477. So what we can say, the maximum possible our percentage of the idleness in the working is of 35%, wherein the minimum possible value can be 33.523, or maximum higher side value of the occurrence of the idleness is 36.47. Okay, so this is how the number of observations as well as the corresponding value of error or the corresponding possible variation in the observations can be determined using the work sampling. Okay, this example was primarily to show the kind of what you say to how to determine the number of observations for desired confidence level as well as the desired accuracy. Okay, so now I'll quickly show you what I have shown with the help of this example. Like P is the percentage of the time for which activity, P is the percentage of the time for which activity was being performed for a given sample size, and P1 is the rundown, like we started from 0.25 and then it continued to increase. So whatever values are initially identified, they may not be representing the situation correctly. So the actual P may be different from the observations being made at any movement. So that deviation is determined from this equation. I have already talked about this. And when the number of sample size is more, then it is little updated. And when the p value is completely unknown, then we start somehow from somewhere, and then based on the requirement of the confidence level, the different coefficient values are used, as I said earlier. Okay, then this formula is used for determining the number of observations desired based on the confidence level and the error or accuracy required. Okay, this P is the occurrence and occurrence percentage, and N is the number of observations being done. So example, I have already talked about this, so that's it from this side. Now how to do it and what is done basically. So as I said, when we are getting ready for the work sampling, we have to see like what is our main objective of a study. Will we trying to look for the working or idleness, because it will indicate like whether something is working or something is not working. Okay, so it will be giving the percentage of the time something is happening, percentage of occurrence of the things which are happening in the shop floor, and thereafter we may have further interests to see the idleness is due to what or the working on what. Okay, so when we are interested in idleness is due to what, then we can see, okay, machine is idle. Then you can also try to determine the percentage of occurrence due to certain things. So machine is idle due to the repairs, lack of supplies, or the workers' personal needs, or it is idle without any reason. And when the machine is working, then also you can say that what is being done by the machine. Okay, so depending on the kind of the job being done by the worker or the kind of the things being done by the machine, so that can be classified, or that its percentage can be, like say if 480 snaps during the day are taken in a shop floor, okay, then you can see really what is the proportion for which cutting is being done in a day, what is the proportion for which boring or the fitting kind of the job is being done. Okay, so that kind of things can be done. This is a simpler thing, like obviously for compiling the information during the sampling, you have to design a form, and the form design can vary significantly depending upon the need. So what we try to mention is like the date and the operator is fine, like who is being studied and who is conducting the study. Thereafter, like a schedule of observations. This is very important, like it can go 1 to say 480. Okay, so when these 480 observations will be done, it may start say 710, then 712, then 715, it may go like this. So those specific times when the observations will be done, that is identified. With thereafter you can also mention the worker who will be observed, or the kind of shop floor which will be studied, or the group of machines which will be studied. And then you will try to identify what is happening. It is working, so you can quantify it is working, or it is not working, you can mention the not working. So for every observation something will be mentioned, working, not working, like this. Okay, so working, then it will be ticked simply here, not working, then it will be ticked here. So there is a particular method of a ticking also. Let me show what is that. Okay, so there is a ticking method also, like say this is the observation. So what we will be doing, we'll keep on putting these 4 lines for 4 observations, and then for 5th observation it is a cross is made like this. Similarly, if we want to see really how many working conditions are there, how many times the worker is found working or not working, then this is how it is quantified. Okay, 1, then 6. Let's say if it is the 6. So this is how it is done. Maybe it will come in the next slide. So this is how the form is designed actually when working. This is an additional information which is used, like rating the performance, as I said. So when the worker is found working, so you keep on ticking every time, and say out of say 48 number of observations, you have found 40 times the worker is working, and every time you can record also the way by which you feel worker is working perfectly, or he is working is fast, or he is working is slow. So when worker is working fast or when the worker is working slow, so accordingly he can be rated. say 100 for the conditions when work study man feels that he is working at the pace at which he should work, and later on if he finds that no, he is working fast, so he can be rated 110 or 120. If he is working slow, then it can be rated like this, or it is reverse. Okay, let me clarify this aspect little later. Sometimes this is just reverse also. So this rating of the performance is important in quantifying the time a job should take. So the worker's performance is rated with respect to the standard of performance of the job in view of the work study man's performance. Okay, how does he perceive that the speed or the pace at which work should be done? So based on that, the workers are rated. Okay, non-working, certainly there is nothing like rating. So that's it. This is another very interesting thing. Like as I said, the observations, whether it is 40 or 480 or 50 or 100 observations, whatever observations need to be taken, how to identify the time when observations should be done. So the different organizations and the companies have developed their own random tables. These are the random tables. These are known as random tables. So in a typical, this is a one typical random table. So what is done, like the paper is taken and her eyes are closed, and then using pencil, the work study man will be putting the pencil anywhere in this table. Okay, so say it is started from this one 11. So this is the first point 11. Okay, and say for the study of a period of 480 minutes, it is desired to conduct the 48 number of observations. Say it is desired to conduct the 48 number of observations. So entire period is divided, say here. So say 480 divided by 48, so you have got 10 value. Simple, it is simply straightforward kind of thing. It is nothing, it can be anything also. Like if you have to conduct 480 number of observations for 480 minutes, then this value will be corresponding to 1. How it is used, it can be 2 also, depending upon the number of observations to be carried out and study period or the study duration. So how it is used, that's what I will tell. So like after closing the eyes, we place the pencil over the 11. Okay, then we'll choose any number, like say 1 or 2 or 3. So we have to skip now certain numbers. So say alternate one number is chosen. Okay, so after 11, say this is skipped, then you go 38, right? Then skip 88, 87, then you take the another number 38, 45, then skip 34, 87 is the another number, right? Skip this number 68, again skip this number. So how it is skipping is done, say you have got, so you keep on selecting these alternate numbers. Okay, let's encircle this alternate numbers. Okay, like this, and you select how many numbers, since how many you will select, you select, say number of observations need to be taken are 48, so let's select 60 numbers. So they'll continue to select the 60 numbers like this. Okay, all right, like this. So you continue to do. Now once, say just for an example, we have selected these numbers, say 1 2 3 4 5 6 7 8 9 10. Okay, just to start with. Now all these numbers will be written in ascending order. So it starts where from it starts, let's say 05 is the first, then next number is 11. Okay, next number is 11. All right, this first one. Okay, and 11 has been repeated, so we'll cut this 11 number because 11 number has repeated. So there is no point in taking two observations at the same moment. So it's just like we'll delete any number which is getting repeated. Any number which is coming much more than our the time period of his study, that will also be deleted. How it is done, I'll tell you. Like say if you take 11 number, then it is multiplied by 10, then it is coming say 110. If you take 5 multiplied by 10, say for this 48 number of observations in a study period of 480, so it is coming 10. We are multiplying that 10 number with these numbers artificially identified, randomly determined, so it is coming say 50. All right, then the second number is after this what we have, 20, say so 20 into 10, that will be 200. Okay, so say we'll go back. So say our study time is starting from 7 a.m. right, and will continue to 5 p.m. With some break of say 1 hour or so. So we need to have like 8 hours. Okay, so 7, so 5 and then 4. Okay, so say up to 4 p.m. it will make 480 minutes with a break of 1 hour. All right, so say we are starting our study 7 a.m. So according to this, if we take up this, then 7 a.m. plus 50 minutes. So at 7:50 will be taken the first observation. Then next is 110 is the next one. So you see 7 plus next 1 hour plus 50 minutes. So next what will be the time? This 110 will be used to see after which time or after how many minutes that observation will be taken. So this will be more clear when we will see this example. This is the same thing what I have mentioned. Like we started with the 38, then continued with the numbers like this, skipping one or more, skipping one number, and these random numbers were identified. Okay, and then these are written in ascending order like this, like 5, 11, 14, 15, 20. Okay, any number which is greater than, because what we have in our hand is like 48 is the maximum random number that can be allowed if we are multiplying with the 10. So it will be giving us the maximum allowed study period of 480 minutes. Okay, and anything which is coming, any number which is coming in between, that will be simply discarded. Okay, so here let's say study started at 7 a.m. so the first observation is being made here. Okay, and the next observation is being made right 8:50. How? Because 60 plus 50. Okay, 60 plus 50 is 110. So 60 is like 7 to 8 is the 60 minute, and then 8 to 9, 8 plus like extra 50 minutes will be coming from here. So 8:50. Okay, then next is 140. Okay, next 140 means 2 hours 20 minutes. So starting from 7 a.m. 2 hours 20 minutes will be at 9:20. Okay, 9:20 a.m. So this is how the time at which the observation should be taken is determined. Okay, so likewise there are number of observation tables have been developed. So it's fine, like there can be different other ways also to find out the randomized times when the observations will be done. Okay, this is just for an example I have taken up. How to record and analyze these observations. So let's say in this observation sheet the number of observations are 75. Okay, so date, time, and etc. study number is fine. So how many times the machine is running, how it is quantified. Every time you see the number of times the machine is running, you can just make it, mark it like this. So it will be easy for counting. So like say 5, so 1 2 3 4 5 6 7 8 9 10 11 12. Okay, so this is leading to 5 into 12 60 and plus 2. So that's how it is easy to count. Actually summary will be easy if it is done like this. And here it is direct 13. You can say 5 into 10 and 3 13. So so this 62 divided by 75 will give us the percentage of occurrence of the machine running time, or percentage of idleness will be like say 17.3, like 13 divided by 75. Likewise there can be other examples also. If you need more details, then this is the same thing, but if the machine is idle for say 13 number of 13 number of times, it is observed that the machine is not working, then what are the reasons behind that why machine is not working. So that also can be noted down, due to the repair it is idle, due to lack of supply it is idle for 6 times, due to personal needs it is or due to the worker it is idle for once, and it is idle without any reason is say for 4 times. So the percentage of uh, the regions contributing to the different percentages, or the idleness being contributed by the different factors can vary significantly, and that is what can be determined from here. So what it suggests that the percentage contribution of the idleness coming maximum from the lack of supplies and without any reason. So these need to be prioritization of the factors contributing towards the idleness can be identified to see what are the things which can be taken up to reduce the idleness. Okay, so this is about the analyzing, and this is a typical observation data sheet only. Work sampling observation sheet, study is of this welding job of this particular component, date of study, and the operators being studied, like say 10 number of observers, and a study is conducted by so and so. And this is about the schedule when the study was done or observations were made. I'm in lecture, I'll call you later. Okay, so the observer, the operator observed here, and then based on the observations, 50 number of observations of the different workers at different times, the percentage of occurrence of working or the percentage of their idle time is identified, or percentage of performance rating is identified. So when they are not working and when they are working, and if they are working, what is their performance rating is identified. Okay, so here in work sampling, what we can see primarily, the maximum performance is rated 100, and thereafter if someone is working less at lower pace, or if the work studyman doesn't feel that he is working at the right way, then his performance is rated less. But in time study you will see it is just opposite, like a worker is working extremely fast, then he will be rated like 90%. If he is taking longer time, then it is just opposite, he will be rated 110 or 120. So there are different ways, I will explain later when we will talk about the time study. So here it is maximum of the 100%. Okay, so average, if we see out of these 50 number of observations, if it is found that the welders are working for 40 times, okay, and 40 times it is observed that workers are working, and their average performance rating is 88%. Okay, 10% of the time, 10 times they are not found to be working. So this is a study period of say 9 hours, 1 hour break, so 480 minutes. That is the kind of scene as far as the number of observations are concerned and their working is concerned. So if you see the percentage of the time for which operator is working is like say 40 divided by 50 into 100, so this will be 80% of the time worker is found to be working, and then the rating is average rating is coming 88%. So if we know like out of 480 minutes what is the output, okay, output, then this output can be this output can be used considering the total time, performance rating, and this output. These three can be used to find out the time for producing unit product. Okay, so that's how we can set the time standard if the allowance is added. Okay, so we know the output, we know the study period, we know the performance rating, then we can determine the time each product is taken for the production purpose. Okay, this is what will be demonstrated from this example. Okay, say total study duration is 1500 minutes. Okay, 1500 minutes is the total study period, and whenever the work sampling was performed, it was found that 80% of the time workers were working, so working fraction is 80%. Okay, and the average rating of the worker is say 90%. All right, and the output in terms of say loading of the goods, loading of the product is 360. This is output only. It may be like say something is being produced or something is being done by the entire system of the personnel or the man and machine system, like that. Okay, so then allowances to be given is 13%. So how to set the time standard? This is the total time of study and the working fraction. So actual working time is how much? 1500 into the 0.8, that is the 80%. This is the actual working time, and the number of units being produced, it is say 360. So this is the actual one. Now based on their performance rating, we can multiply. Now for the performance rating, actually they were working slowly, that is why the normal time will be less. If they were working exactly at the pace at which they should work, then it would be 100%. Okay, so here what we'll be getting based on this performance rating, 1500 into the working fraction time, number of units being produced, and the performance rating. This will give us this is the time for producing the unit goods, time for producing the per unit product, per loading of unit product in this case. So each unit is loaded in 3 minutes. So if the allowances are to be added, then on adding the allowances, it will be like say normal time 3 minutes into 100 divided by the 100 minus the allowance allowed. Okay, so this will give us the 4.36. This is how the standard time is identified. So entire work sampling approach, as you have seen earlier, entire work sampling approach was primarily in determining the percentage of occurrence. You see, whatever we have seen, this is the period during which the study is being done. This is the total output. This is the as a policy allowance allowed. This is the observation made by the worker during the study. But whatever is the working fraction that is identified, this is determined from the work sampling. Okay, so work sampling was primarily used to identify this percentage of occurrence, and then it can be simply used to set the time standard. Okay, so that's how we complete our this section related with the work sampling. Now very simple section that is about the advantages and disadvantages of the work sampling. I'll quickly go through this. Let me check how much time. Okay, so we can finish this. Work sampling can be applied to the group of workers. That is very good part. So the number of workers and the number of machines can be studied in one go, many operators and worker, but it will not be feasible for a study of the one. Okay, uneconomical. So here many operators and workers which are difficult otherwise. So when number of things, number of machines and number of workers are to be studied, this approach is extremely good, which is otherwise uneconomical by the time study approach. Okay, so 2 or more studies can be done at the same time on the several machines and operator in a single study. That's good. This process is very fast. Fewer machine hours are needed to make the work sampling study, and it doesn't use the stopwatch and other time measuring devices. Okay, and this may be stopped at any time without affecting the results, especially because the time study once is started, it has to be continued until the job is completed or the study is completed. The study is not done by being close to the worker, so it gives us more normal time of the percent, because it doesn't give the time, it gives us the situation whether either worker is working or worker is not working. So operators are not watched closely, so his working is not affected. That's the point. And a worker may not follow his usual routine daily. So this is the problem. Like in the time study, worker, if worker doesn't feel good or hello. Okay, so worker may not follow his usual routine exactly during the study period. So that is the problem in case of the time study. But here what we see, like if the worker is only working or worker is not working, and then based on his pace of the working, he is rated. And the number of observations may be taken. Very large number of observations can be taken over the study period, which can run for a number of hours, days, or even months also. Okay, like the work sampling studies are preferred as compared to the continuous study. This is really undesirable on the part of the time study, and these are less fatigue and less tedious as compared to the time study. So these were the some of the advantages as compared to the time study, but if only the single worker or single machine is to be studied, then this is uneconomical. It's really more useful when many operators, machines are to be studied. And important thing is, another undesirable aspect related to the work sampling is it doesn't give the elemental time. Like what is the time for which the job is being machine is being set, job is being being machined. That is also not there. Actual machining job, actual unloading job. So time. So those time for individual activities is not obtained in this. It gives us the total time and the total output. Based on that, that standard time is set. The operator may change his working pattern. It doesn't check really if the worker is working correctly or not. But in the time study, everything is seen very carefully. So the pattern of the working or working methodology is not checked in work study, and there is no record. Only snaps or photographs are taken. And as compared to the stopwatch, the approach of a statistical approach of work sampling is difficult to understand by the workers. So these are some negative points as far as the work sampling is concerned.